Greetings, I'm Squared here, and today we're going to talk about graphing piecewise functions. So just a little review about piecewise functions. Piecewise functions are functions that have different rules for different intervals or different parts of the graph. You can see that there's two different lines graph. They're parts of lines, right? They don't go all the way through the graph. Starts here, and goes that way. So you can see that they're different rules, which means they have different slopes. They have different y-intercepts. This one has a y-intercept of 0. And it goes up 3 and over 2 for the slope. This one has a y-intercept of 3, and then it goes up 3 over 3, which would mean our slope is -1. And you can see that right here too. This one, oh, did I say a 3? It must be 4, 2, because it has a slope of 2, excuse me, and a slope of -1. So what we're going to do today is we're going to be given rules, so a name, function rules, and the domain intervals, and we're going to have to graph them. So we talked about writing last time, now we're going to talk about graphing. So we're going to look at this one first. So we want to graph one at a time. So this one says to start at x at -3 and to graph the absolute value of x for all values that are less than -3. Notice it doesn't say equal to, so we just are going to start at -3 and go less than. So I always like to start at -3 and put a circle around it to hopefully remind myself that it's not a dot there, it's going to be an open circle. And then I continue to go less than. So I'm going to graph a few points that are less than that. So -3, if I plug it into the absolute value of -3 is 3, the absolute value of -4 is 4, the absolute value of -5 is 5. And because I know that this absolute value sets at 0 and I'm going to only start at -3 and go that way, I know I don't have to have a v. It's going to look like a line, really, this function right here, when it's left of -3. So I'm going to go over 1, 2, 3. I'm going to go up 3, but I'm going to put an open circle there because it doesn't actually exist there, but it goes right up until that point. Then I'm going to go to -4, 4, -5, 5, etc., etc., etc. And for my etc., I'm just going to use an arrow. So I'm going to draw the line and the little arrow. So it doesn't really look like an absolute value, but that's because we only graphed part of it. The other part would go like that. So that's that part. Now I'm going to use a different color to kind of go for this rule. So we have two rules that we're working with here. So -1/2 x -1. That is what we're doing. And this time it says it's equal to it. So we've got a -1 that it's going to go right up against. And then it says numbers bigger than -1. So -1 is, because of that 1/2, I'm going to choose even numbers. Except for that one right there, because I need to know what that is. So if I put a -1 in there, I get -1.5 or -1.5. If I put a 0 in, I get -1. If I put a 2 in, I get 1 minus 1. If I put a 4 in, I get 2 minus 1. So that's one way to do it. The other way to do it is to actually graph this using your slope and your y-intercept. So because this is a little bit left of 0, I can actually go -1 and then go up 1 over 2, up 1 over 2. I could graph it that way as well. -1, -1.5 is right here. And then you see the 0, -1, the 2, 0, and the 4, 1. I just graphed it a little bit differently. You can see you can do it both ways. So this is our piecewise function for this rule right here, for these rules right here. So 2 lines, even though that looks like an absolute value, 2 lines. Okay, let's try another one. One more. Notice this one has 3 rules. So it has 3 intervals. So from points less than -3, so that's -4, -5, we're going to have this interval. So if we put a -3 right there, we got -3 times -3, which is 9, plus 4. 9 plus 4 is 12. If I put a -4 in, I'm going to get 16. And that is off my grid. So this is a 10 by 10 grid. So that means I'm going to have to be careful because I'm going to have to count by 2s. So I want to just be careful with that. I want to make sure I mark it because if I'm going to count by 2s, I'm just going to count by 2s everywhere. So if your graph paper is too small, that's always an option. And then, of course, this one would be 15 plus 4, which would be, right? 15 plus 4, yep, which would be 19. Something seems off there. Did I do that wrong? Negative 9. 13. That's a 13. Sorry about that. So it goes up. I could tell it was wrong because it wasn't going up by 3s each time. So my apologies for that. All right, back to this guy. If we want to graph that, we have to go to negative 3, which is right here, and then we have to go up 13. Remember, I'm counting by 2. So 2, 4, 6, 8, 10, 12, 13 would be right here. And that's my lowest point. I need an open circle right there. So I'm going to make it an open circle. And I'm going to go to negative 4, which is right here, and then 16. So this was 12, 14, 16 right here. And then at negative 5, I was at 19. So that's right there. So I am going to connect those dots. And that is my first rule. My second rule just says it equals x. It means I have a slope of 1. So between negative 3 and 2, it's just a slope of 1. So, and a y-intercept of 0. So if you know how to graph that without making a chart, you can, but if you need to make the chart, since I know it's a line, I would just use those 2 points and connect them. So when I put a negative 3 in for x, guess what I get? A negative 3. When I put a 2 in, guess what I get? A 2. So at 2, 2, remember I'm counting by 3's again, so it would be like this. So I'm going to connect those dots, but there's no arrow this time, so it's just that little piece right there. Okay, last one is for anything that's greater than 2. So 2, 4, 8. I'm going to choose numbers that are divisible by 4 because of that fraction right there, except for the first one. So, and 12. We'll just do a few. So if I put a 2 in there, I get 1/2 minus 6, which I believe is negative 5.5. If I put a 4 in there, I get a negative 5. If I put an 8 in there, that gets me a 2. So that's a 2 minus 6 is negative 4. If I put a 12 in there, I get 3 minus 6, which is negative 3. So I'm going to go over to 2 and down 5.5, which is supposed to be an open circle, and over 4, down 5, 2, 4, 5. So that was, let's look, little 5, then at 8, I'm at 2, 4, 6, 8, I'm at negative 4. And 10, 12, I'm at negative 3. So you could use graph paper where you didn't have to count by 2s because it does take a little more concentration. And so that is my piecewise function for this function. I have 3 different rules. Open circle. And then I always like to go back and check. Yes, did I do an open circle that? Were these 2 closed circles? Yep. Did this one have an open circle? Yeah. So it's just a matter of graphing the line separately and only for a certain number of x's. So remember, if it says less than 3, I chose those numbers first, so I'd be sure to only choose numbers that were less than that, or between, or greater. Okay, good luck with that. M squared, signing out.